Hey everybody, today we are learning our fourth and final transformation. This is called a dilation. You might have heard that word before. Usually it's in reference to whenever, I don't know, somebody, flashes a flashlight in your eyes, your pupils dilate. So that's like the black part of your eyeballs. Um, and what that means is they kind of change in size, right? You've seen it before. Your eyeballs get bigger, smaller. That's called dilation or dilating. All it is it's a change in size, and we're going to use that same mindset here for these types of transformations. So um, a transformation, as it's been through the entire unit, is where we take the pre-image and we will transform it somehow to this new figure called the image. Okay, um, yeah, that hasn't changed. So a dilation, what we want to think about it as is it's a transformation that is either going to enlarge, so enlarges or reduces a figure by a scale factor. I'll talk about that in a second. Enlarges means to make bigger. Reduces means to make smaller. Okay. Um, so this scale factor is actually a really, really important part of this because it kind of tells us how big or how small we are going to be changing these pre-images. So a scale factor has the word factor in it, and if you think about what factor means, that's the part of or it's a number in a multiplication problem. So what we're going to be doing is we're going to be multiplying these ordered pairs by a scale factor. We do use a variable for scale factor. That variable is the variable k. I'm not good at drawing k's. It's a k, trust me. Um, and what it is, like I said, it's going to be the factor multiplied to enlarge or reduce a pre-image. And I'll tell you, based off of the scale factor, kind of when we get to it, what to expect when we do that. All right. So if you think back to the reflections set of notes that we did, right? When we did our lines of reflections, we only used the x-axis and the y-axis. Even though you could use a line of reflection for anything, we only did the x and the y-axis. When we dilate something, you have to dilate something from a specific point, and you can use any specific point, but for our purposes, we're just going to use the origin. That point is the center of dilation. So if you look at kind of 1 and 2 here, uh, these two figures have already been dilated, these triangles and these square rectangles, right? They've been dilated in relation to the origin. That's the only location that we are going to dilate our points from. All right, so that's kind of the whole center of dilation explanation there. All right, so what do we do? How do we do this? All right, so we need to find scale factors when things have already been dilated, as 1 and 2 have already. We want to know, okay, how have they been dilated? Like, what did they get bigger? Did they get smaller? And by how much? So we're going to find a scale factor. Specifically, I'm going to work with number one, and you're going to try number two. The first thing that we have to do when we see two figures like this is understand which one is our pre-image and which one is our image. So just kind of look at one of these points. I'm going to pick B. And we should know, based off of kind of how we've been learning what the image and the pre-image look like, which one of these is the image and which one is the pre-image. Um, so what I've highlighted, that green triangle has all of the prime uh, points. So A prime, B prime, and C prime. That's going to be your image. So that's going to be what happens after the transformation from the blue triangle, which is A, B, and C. All right, so it looks like our figure is going to be getting bigger. and we're going to figure out kind of how. The first thing that we need to do is compare the ratios of corresponding sides. You've seen this word ratios before. That means fractions. So we are going to make fractions, but they're not that bad. This corresponding sides, that basically just means which sides relate to what. So in my blue triangle, what sides relate to the sides in the green triangle. It's pretty obvious for the most part in a situation like this. So what you want to do, and you kind of have it, I already have it set up down here, but you want to place the image line or the image side in the numerator, and then your pre-image side in the denominator. Okay, so kind of looking at number one on a bigger scale here. So you'll notice that I have A prime, B prime in the numerator. What I'm referring to with A prime, B prime is the side from A prime to B prime. And then from AB down here, that would be the side from A to B. All right. So we're just going to count these to kind of set up our fraction or our ratio. So from A prime to B prime, it's just 1, 2, 3, 4, 5, 6. So our numerator will be 6. And then from A to B is 1, 2, 3. So we have 6 over 3. The last step you can see on the left is just simplify. So 6 over 3 is a ratio, it's a fraction. 6 divided by 3 is 2. Okay, so what we just found was the scale factor of these lines B or A prime to B prime and A to B. We found that the change was 2. All right. I did give another example here from C prime to A prime and then C to A. So let me just go ahead and kind of highlight those, just because you want to make sure that you get at least 2 of these sides having the same scale factor, because sometimes it won't end up being a dilation. But so from C to A, or sorry, C prime to A prime, it looks like we're going to have 1, 2, 3, 4. So that's going to be 4. And then from C to A, you can just kind of count that pretty simply. 1, 2. So that's going to be 2. So we have 4 over 2, which also is 2. So we can safely say then that the scale factor from ABC to A prime, B prime, C prime is a scale factor of 2, which is going to be, and you can tell from the figure here, we went from a smaller triangle to a larger triangle. So this is going to be an enlargement. All right. So I want you to pause this video. I've already set up highlight that. I've already set up which sides I want you to try on the square to the right. So go ahead and pause this video, see if you can find your scale factor. Okay, hopefully you paused the video. If you didn't, well, here we go. So R prime, S prime is, it looks like 1, 2, 3, 4, 5. Looks like it's going to be 5. And R to S is 2. So that would give us a scale factor of either 5/2, or you could say, which it really doesn't matter, but you could say 2.5 or 2.5. Okay, any of those are fine. Let's just do that because you guys like decimals better. So 2.5. Okay. If this is a dilation by the same scale factor, then we should get 2.5 on our U to R situation here. So U prime to R prime. Oh no, I got this backwards, didn't I? I did it backwards. All right. Let's restart this then. So r prime to s prime is actually the smaller square. I messed up. That's on me. R prime to s prime is 2. R to s is 5. So I had it upside down. So really what this is this is going to be a scale factor. I'm going to leave it as a fraction. It's going to be a scale factor of 2/5 if the u to r kind of works the same. So from u to r, you can count that. It is going to be 2. From or u prime to r prime is going to be 2. U to r is going to be 5. So we did get the scale factor. It is 2/5. Boy, that was brutal. Okay, this would be called a reduction. Okay, this is going to be a reduction. So I want to say this before we go to the back and actually use these scale factors. When k, all right, when k is greater than 1, you have an enlargement. Okay, when k, so remember k is our scale factor. When we have k being, how do I set this up? If I have k is less than 1, but it has to be greater than 0, because you can't have a negative scale factor. Okay, you cannot have a negative scale factor for our purposes here. So it has to be between 0 and 1. That's going to be a reduction. Okay, so just kind of something to be aware of. All right, so that's kind of how we identify scale factors. Okay, enough about that. Let's use them. So going to the back side, we are going to draw our pre-image and then dilate the figure. I'm going to do these first two, 3 and 4, and then I want you to do 5 and 6. So for 3, I'm going to draw my pre-image. So A is going to be at -6, -2. Here's negative 6, -2 is here. Name it A. B is -2, -2. C is at -2, -6. And D is at -6, -6. So we have it looks like it's 4 by 4. So this is a square. Okay, this is a square. Go ahead, connect your dots. All right, make your best square that you got there. I missed a little bit there. Okay, that'll work. All right, that will work. So we have a scale factor of 1/2. All right, we have a scale factor of 1/2. What would happen here then, based off of kind of the front side, is that we would expect this square to get smaller. So what I want to do, because remember, so I guess let me just put this out here. If we have an x and a y, because the rule wasn't on the front side, if we have an x and a y, our rule is going to be taking the scale factor times x and the scale factor times y. So you're going to see me do that down here on these lines. It's going to look like a lot of work, but honestly, it's not too bad. So for A, our point of A is -6, -2. So -6, -2. We are going to then use our scale factor, which would mean we're going to take our scale factor of 1/2 times the -6 and the -2. Right? And then what we'll get on the other side of that is what point A prime should be. So half of -6 is -3, and half of -2 is -1. Okay? I'm going to do the same thing with B. So B, actually what I'm going to do is I'm going to write all of these first just so I don't have to keep changing colors. So B is -2, -2. C is -2, -6. And D is -6, -6. All right. So all of these are going to be using that scale factor of 1/2. So I'm going to be taking 1/2 times all of these ordered pairs. So half of my -2, -2, half of my -2, -6, half of my -6, -6. All right. And then what we're going to have left is our dilated points. All right. So half of -2 is -1. Half of -2 is -1. Half of -2 is still -1. Half of -6 is -3. And then half of -6 is -3 twice. Just because I got a lot of colors working here, let me just highlight what our A prime through D prime actually is. It's going to be these 4 points. All right. I will say, and this is just me off the top of my head here, I will say that this is one of those where you have to use the rule before you can graph these or before you can plot these. You have to know what you're plotting before you can just go for it. All right. So A prime should be at -3, -1. That's going to be A prime. B prime should be at -1, -1. C prime should be, and I see where this is going already. Whoops. Move him on the inside. C prime should be at -1, -3. I'm going to have to move that B again. C prime is here. Yep, it's going to have to go. Let's just put it back here then. That's fine. And D prime is going to be -3, -3. Okay, so I'm going to connect my dots, obviously. And what you'll see is we still have a square. We could check the scale factor by doing what we did on the front page, but we don't need to. That square right now is 1/2 the size of our pre-image, which is what I have in blue. Okay. Take a breath. It seems like a lot of work. I'm just kind of dragging it out a little bit. Okay. It does move faster when you do it on your own, and I hope you see that on 5 and 6. But I'm going to run through 4 with you again. Let you do 5 and 6. We'll come back, and that'll be it. So number 4, again, we need to plot our pre-image. So W is going to be -1, +1. So that's W. X is 1, 1. I hope we don't have another square. It'd be poor planning on my part. Y is 2, -1. Okay, we don't. Z is -1, -1. So it's down here. So it looks like we got us a bit of a trapezoid. All right. Make sure that you have labeled everything here. Connect your dots. Should form us a nice trapezoid. Or a square, I guess, if you're trying to be fancy like me. That's a trapezoid. There we go. Okay. Looking at our scale factor, we have a scale factor of 3. So we would anticipate that this thing is going to get bigger. If we do our work right, it will. So again, the first thing that I'm going to do is write all of our original coordinates so we can show the work down here. So W is at -1, -1. X prime, or sorry, X is at 1, +1. Y prime is at 2, 1, 2, -1. And Z prime is at -1, -1. I am going to just double check because I can't see it on my screen. So -1, W is at -1, +1. I knew I was going to mess up. So that is going to be here. X is at 1, 1, 2, -1 for Y, and Z is at negative. Okay, we're good. All right. So Now I'm going to write the rule. Okay. In this case, our scale factor is 3. So we are going to be multiplying all of these coordinates by a positive whole number 3. So we're going to take 3 times the negative 1, 1, 3 times the 1, 1, 3 times the 2, negative 1, and 3 times negative 1, negative 1. All right, so that is essentially our work. We just need to kind of finish this. So 3 times negative 1 is negative 3. 3 times 1 is 3. We just found out 3 times 1 is 3. So we've got 3, 3 for x prime. 3 times 2 is 6. 3 times negative 1 is negative 3. And you can see, like, actually, as we go through this, you can see that these numbers are getting larger, okay? So that should be a good sign for us as we continue to multiply here. So these should be our prime coordinates for this figure. So let's go ahead and see if we did everything right here. So W prime should be at negative 3, 3, 2, 3, 1, 2, 3. X prime should be at positive 3, positive 3. Y prime should be at 6, negative 3. 6, 1, 2, 3. And Z prime should be at negative 3, negative 3. Oops. Connect your dots, and if we did everything correctly, that's terrible. If we did everything correctly, we should have just a larger trapezoid. There we go. Okay. I know this line's not straight, sorry. That's not much better, but that's okay. All right, so that's kind of how this works. It's a lot, again, it looks like a lot of work, all right? But what I want you to do, I want you to pause this video, and then I want you to try 5 and 6. And when you're finished with that, you can go ahead and head to the sub and pick up your notes. All right, so this is what I got. Hopefully there was maybe a weird jump skip if you didn't pause. I'm not sure. I figured out how to pause on this thing. Maybe it screwed up. I don't know. Doesn't matter. Yeah, so this is what I got. Okay. We had a scale factor of 1/3 for number 5. So I would anticipate my blue triangle, which is my pre-image, to get smaller because 1/3 is between 0 and 1. So I kind of did that math. Notice I didn't show my work. That's okay. I'm sure you probably did because I didn't tell you not to. Sorry, please don't hate me. And 6, our pre-image was the blue triangle, as I normally do here, but we had a scale factor of 2. So we would anticipate that triangle to get bigger. Do these look like, the 6 look like that triangle, that purple triangle is exactly twice the size of the blue triangle? Maybe. Maybe it does, maybe it doesn't. But the math says that it is, so we have to trust that. Plus, I think it's kind of weird because remember, our center of dilation here is around the origin. For 6, that blue triangle is like surrounding the origin. So it's kind of just going to go more outward than it is kind of in a different direction. But anyway, I'm rambling. Go get your homework assignment, get it done. I'll check in with you tomorrow. Remember that tomorrow is clear sight. So make sure that you bring a charger or your charge device. Headphones, bring those if you have them. And then we're going to not have phones and smartwatches and all that jazz. But get your homework done. We'll go over it tomorrow.